Hi everyone, and welcome to the probability sampling lecture video. In these last two videos, I want to go through the different sampling methods. In this video, I'm going to explore those methods that specifically employ random sampling, and then the next video we'll talk about non-random sampling methods. Remember that random selection was a key to help to increase the representativeness of the sample, which then allows the research findings to be generalized from the sample to the population, and it gives the study external validity. Any method of sampling that uses random selection is known as probability sampling method. Now there's an important part of random selection that's known as EPSM, or the equal probability of selection method. EPSM means that every person in the population, no matter who or where they are, has an equal chance of being chosen to participate in your research study. Now this is really important because it's a common misunderstanding about random selection. People think of random selection as just randomly pointing to different people and saying, you're in my study, so you'll be in my study. But random selection in sampling is so much more. First, in order to ensure that every person has an opportunity to be in your study, you have to start with a list of every single person in your population. That list is what we call a sampling frame. It's the starting point for any probability sampling method. If you cannot get a list of everyone in your population, then you will have to do a non-probability method, which we'll discuss in the next video. There are 5 major probability sampling methods that are typically described in methods textbooks. I'm going to go through the first 3 with you. Cluster and multi-stage sampling are really important and also very common methods of sampling, but they're also a lot more complex than the first 3, and so I think they're more appropriate to an advanced or graduate methodology course. In my course, you'll only be responsible for learning and applying these first 3 types of probability sampling. Let's start with simple random sampling. In simple random sampling, it's an easy 2-step process. First, you assign a unique number to everyone in your sample. Then you randomly pick numbers in some method and identify which participant those numbers represent. Typically, researchers will use random number generators or lists of randomized numbers to choose the final sample. There is also the quintessential version of simple random sampling, and that's shown here. It's to throw everyone's number into the hat and then pick out the number of people you need for your sample. The best part of simple random sampling is that it's super easy to do once you have the sample list. The problem is the construction of the sample list. You have to know the entire population in order to assign everyone a unique number, and that can be challenging if you're working with a population that it contains hidden or transient person. Assigning everyone a unique number can also be time-consuming, particularly if you're doing so manually. You'll get a chance to see what I mean in this week's activity, but don't worry, I don't make your sample too big. Systematic sampling works very similarly, starting with a sample where every element is given a unique number. But instead of randomly picking numbers, systematic sampling uses a selection process where you pick every kth person. K stands for the sampling interval, and it can be any number. The way to calculate K is to take the total number of people in your population and divide by the sample size that you want to create. In this example, you have 9 people in the population. If you want a sample of 3 people, you take 9 and divide by 3. That leaves us with a K of 3. Once you have every K person, then you go through and you pick 3rd person, 6th person, 9th person, etc. Now, the biggest concern with systematic sampling is the impact that patterns in your data set will have on your final sample. Let's say every other person in my sampling frame is a boy. So everyone with an even number would be a boy and everyone with an odd number would be a girl. That means that a K of 2 would exclude all of the boys from the sample, and a K of any even number would exclude all of the girls from the sample. So we want to make sure that our sample list does not have an organizational pattern or a structure before using a systematic approach. Stratified sampling is the way to get at more complex topics. Stratified sampling is a 2-stage process. In the first stage, you create multiple sample groups called strata. The strata will consist of all the elements in your population grouped by whatever characteristic you're trying to study. In stage 2, you then use simple random sampling or systematic sampling to select elements from each strata. All those elements together will be your final sample. So let's say we wanted to know what experience customers had at a new ice cream store in town. One way to go about that is to use simple random sampling or systematic sampling to get a random sample of customers and ask them about their experience. So I gather up a list of the day's customers. There were 15 people in total, and here were their reactions to the new store. Then I decide that I want to explore their experiences more fully. I want to pick 3 people to talk about their experience more in depth. I want to randomly sample from this population, but I also want to make sure that I hear from people that really liked the new ice cream store, people that were like, and people who hated the new ice cream store. That way I can make sure I get a full range of experience with the store before I make my conclusions. To do this, I'm going to use stratified sampling, and I'm going to sort all of the first day customers into 3 strata based on their feelings toward the ice cream store. So I create 3 different groups, one for each attitude towards the store. Then I'm going to use either simple random sampling or systematic sampling to select one person from each group. So first I'm going to number everyone with a unique number, and then I'm going to randomly select from each group. Notice that my numbering scheme starts over for each strata. That's because you're going to treat each strata as its own population. I will then use a random number generator to select a random number. Since each of my strata is different size, I need to draw a different random number for each strata to make sure that all the people in the strata have the ability to be chosen for the final sample. My random number generator gives me 2 for this first strata, so I select participant 2 from the neutral strata. My random number generator gives me 5 for my second strata, so I select person number 5. And then my final random number is 1, so I select participant number 1 from the unhappy strata. I take out all of the customers not selected, and that leaves me with a final sample of 3 people representing all 3 attitudes I noted in my initial survey. The advantage of stratified sampling is that it can allow us to gather a more representative sample than can be obtained from simple random sampling, since you can make sure that you include all of the important groups within your population. The challenge of this type of sampling is that you have to put each element into a single strata only, and that can be really difficult depending on the characteristics being studied. For example, if you're interested in stratifying by race and gender, you have to separate each racial group into each gender identity, which can then make stratified sampling very complex and may require a much larger sample than traditional simple random or systematic sampling. All right, well, that concludes our discussion about common probability sampling methods. Thanks for watching, everyone.